Okay, thanks for the help.
Hey, good afternoon, everybody. My name is Sean Callahan. I'm from the Command and Staff College Distance Education Program, and I'm here to introduce our speaker for today. Before I do that, I just want to thank the Expeditionary Warfare School for hosting this visit. I think you're going to find it very informative, and we have them to thank for this opportunity. The speaker I'm introducing is Franklin Chuck Spinney. He goes by Chuck. He joined the Air Force in 1967 as an engineer. After a couple of years, he transitioned to civilian service as an analyst in the Department of Defense, basically providing some independent policy advice to the Secretary of Defense. And he became known as a pretty central member of the military reform movement, which was an effort to re-examine the way the Department of Defense was buying expensive equipment and pursuing some really unsustainable behaviors. So he became so central in that, he was featured on the cover of Time magazine in 1983. He's been described as the conscience of the Department of Defense. When he retired in 2003, he was honored by the Project on Government Oversight with their most prestigious award. So why is he here today? Because during his time with the military reform movement as an analyst, he became a very close associate of John Boyd. In fact, there's probably few people who understand his theories as well as Chuck Spinney does. He's developed a brief known as Evolutionary Epistemology, which is given numerous times throughout the years. And we've asked him to come here today and share what insights he can give us into the theories of John Boyd. So with that, I'll turn it over to Chuck.
Okay. I'm going to stand up here. I sort of wish it was a smaller room, but I guess we're stuck with what we got. This briefing is a briefing I put together in 1998. It's been updated a little bit since then, and the motivation for it was John used to go up to the Naval War College to teach to be a guest lecturer at a strategy course. The professor of strategy was one of the military reform movement's few guys in the Navy. He was a former diesel submarine officer, and he taught strategy at the Naval War College. And after John died, he asked me to come up and give John's briefing, which I was very, very reluctant to do. And he just begged me to do it. He said, look, it's been the most popular briefing, that everything. I said, yeah, but this is John's work, you know, I can't do it. I'm not the guy to be doing it. Anyway, he persuaded me to do it. And so that's what gave me the motivation to put this thing together. I've got a lot of stuff in here that isn't his stuff that we've added. I'm pretty sure it's consistent with what he would have said. I'll point out those things when we talk about them, so there'll be no confusion over what is me talking and what is him talking. The other thing is I like to do this, and this isn't the world's greatest format for a structured discussion, but I really want you to participate in this and ask questions. Now, is there anybody in the room that's seen this briefing before? Either the text or heard it somewhere? Yeah, Damien has. Well, if you've seen it, you don't get there are certain places where I'm going to ask questions, you don't get to talk. The whole idea is to explore how the uncertainty affects the OODA loop, and I try to run some sort of thought experiments to help you understand that. And people that have gone through it, you know, they can come up with the answer and look smart and ruin the whole thing. So if you know where it's going, zip a lip. Anyway, this is my view of what John wrote in his paper Destruction and Creation, which many people don't understand is the real foundation of his theory of the OODA loop. A lot of people talk about maneuver warfare, and John synonymously. John very seldom used the term. Basically, his theory was built around the OODA loop, and when he said our strategy is to get inside your adversary's OODA loop, he had a very, very precise meaning in mind. And that could work in guerrilla warfare. It could work in what Bill Lynn might call second generation warfare. It could work in first generation warfare. It was a very, very broad-based thing. Anyway, I'm going to try to explain to you what this theory was about and how its foundation was formed. And we're going to get into some pretty obscure or abstruse stuff because it was grounded in science. And basically the thing that motivated this his production of the paper, Destruction and Creation, was in the 1950s, John was a fighter pilot. He was probably the best fighter pilot. He was certainly a candidate for being the finest fighter pilot in the Air Force. He was sent to graduate school, and he came up with a theory of design called energy maneuverability. Now, you people who are aviators have heard the term. John invented it. It was his idea. And it literally, and I was just a design engineer at the time at the Air Force Flight Dynamics Lab. I remember when it hit, and it literally changed the way people looked at the world as far as aircraft design was concerned. And John became world famous because of that theory. I mean, he won all sorts of scientific awards. And he had a degree in economics and a master's degree in industrial engineering, which isn't really a scientific degree, it's more of a management degree. And he became obsessed with how come me, a dumb fighter pilot, came up with this idea when all these PhD aerodynamicists didn't. And so this was his exploration. That's how it started. He had no idea he was going to get into a theory of war when he started. Absolutely none. That was the furthest thing from his mind. In fact, most people thought he was crazy when he was doing this. Myself and another captain in his office thought it was really cool, but we were about the only ones. And maybe that's because, captains working with colonels is a big deal, and so we were probably particularly famous colonels. Anyway, that's where it comes from. If you want to understand his theories of warfare, you really have to understand this thing, or at least be exposed to a good part of it. Wait a minute, what did I do? Oh, that's a pointer. And I just want to put in a disclaimer. This is my view. If you want to see the authoritative view, you got to read his paper. But I think I've done the best I can to keep this thing consistent with his paper. Now, John had a famous quote, particularly after he got involved in the military reform movement, the maneuver warfare movement, and particularly when he got involved with the Marines. He used to say, machines don't fight wars, people do, and they use their minds. Now, I knew him well before he got to that stage, and I never heard him say anything like that before he wrote this paper. This paper is his theory of the mind. And this sort of put it in context. We're going to be talking about, wait a minute, sorry. Oh, Christ. Let's see, I want to go back. Yeah, there we are. We're going to be talking about what's in the green circle here, which ends up down here, which is the foundation statement. Don't worry about it now. Most of the stuff that you people are familiar with, to the extent you're familiar with John's work, has to do with what's in the red here and down here. And this goes well beyond the statement of maneuver warfare. It's basically his idea of war, his theory of war. And then this is the other bookend. This basically is an evolution of this. You got to understand this to understand this and this. And then if you don't understand these two things, this becomes very clear. Any questions? Please ask questions, interrupt. Let me see now. So yeah.
I just had a question about, I noticed in the history and theory there's no naval theorists, it's mostly on the ground side.
Yeah. There isn't much on the air side either.
No.
He was a pilot.
Is there a reason for that, why you focus on?
That's a good question. Is there a reason? I think part of it was ground warfare was very controversial in the 1970s. There were a lot of people who had ideas about how we should have done it better than the way we did it in Vietnam. I think part of it is the fact that the Air Force truly hated John. They tried to make him a non-person after he retired. And the Navy, the Navy's the Navy. They just didn't, they didn't care about that. The Navy has a different view of the world than the other services. The rest of the world exists to support the Navy, whereas, other services don't quite look at it that way. they were perfectly happy with the way they were doing things. And there have been I have worked with a few naval officers, particularly black shoes, surface warfare guys, who were trying to get some of these ideas into action. But they were really unsuccessful. And one of them ended up being a vice admiral. I mean, it wasn't that they got crucified or anything, but they just didn't, they just never got the traction in their institution. So you're right, it's basically ground warfare. I think part of it is another thing is when he started giving his briefings, the people who were interested in it were the Marines, because the Marines had their own movement that sort of came together voluntarily, you know, Mike Wiley and the people surrounding Wiley and Al Gray surrounding those guys in the 70s when Gray was a colonel, Wiley was a lieutenant colonel and a major. And in the Army, it was the opposite thing. They viewed him as a threat, so they took an interest in it so they could torpedo it. So you had the ground forces being interested in it, so it just sort of reinforced itself. So basically the debate was about land warfare. And that's my interpretation of what took place. I'm not sure you can take it to the bank. Yes, sir?
Along the same lines, as we're looking at science and math, is there a reason why biology, so there's other disciplines like psychology, anthropology, sociology, is there any reason specifically why biology isn't highlighted?
That's a good question. There shouldn't be a reason.
Evolution and natural selection.
Yeah. Yeah, I mean, that's a really good observation. This is a chart made by my colleague, Chet Richards, who is very close to John. And I'll have to ask him why he didn't put it on this chart. It's a good chart, and Chet's got a PhD in math and theoretical math, and he understands a lot of the mathematical theory better than I do. He had this chart, and I was thinking, oh, this is a good way of looking at it. He was very interested in biology. I know that for a fact. It should be on it. You're the first guy that's noticed that, by the way. Any other questions? Okay. Oh, wrong one. Sorry, it's going to take me a while to get up to speed on this thing. Okay, so the aim of his paper and the aim of this briefing is to try to understand how the mind evolves its internal orientation, or what you might think of as changing contexts of meaning, or what Thomas Kuhn, a philosopher of science, called paradigms. It's interesting, that's a much abused word. How many people in the room have heard someone say, usually someone who was their boss, say, we got to change our paradigm? You know, yeah, everybody. When Kuhn was on his deathbed, he is reported to have said that he wished he'd never invented the word, because it's really been abused. But basically, it's your internal constructs of meaning, and it basically permits people. Oh, damn it! Oops, sorry. Permit individuals and groups to cope with changing conditions or a changing external environment. So you can see the person who just asked about the biology was you. Yeah, I mean, this is very biological. So our point of departure is going to be, how do we make decisions, or why do we make decisions? And the biological imperative creates purposeful behavior and goal striving. Basically, we want to survive on our own terms, or more generally, try to improve our capacity for independent action. And we have to do that in an environment of constraints, limited skills and resources, which limit our capacity to reach that goal. So you have a combination of goal striving and scarcity sets the stage for competition among individuals and groups to overcome the environmental constraints. And of course, that sets the stage for conflict. And the consequence is that to survive and grow relatively free of debilitating constraints, individuals and groups must make decisions, take actions to overcome those obstacles. So this is our point of departure. Now we're going to try to show you how this comes into being. Oh, shit. No. Christ, I forgot to put it on. Do you know how to, can you put that on? Yeah. Let's see if you can put it on an airline. I'm sorry. So our focus is going to be, how do we generate, oh, damn it. how do we generate the mental concepts needed to support that activity? That's what we're going to discuss. And put another way, how do we evolve concepts to identify what decisions and actions are necessary and appropriate, and monitor the effects of those actions to support subsequent decisions? Now, you've all probably heard of the OODA loop, and this is sort of a typical thing that you might see. How many people have seen something like this? Yeah, everybody. You know, you cycle through, you observe, you orient, you decide, you act. Basically, there's some problems with this portrayal, though. Does anyone have any idea? What's wrong with it? This is the wrong way of looking at it. Nobody? Yeah. Yes, sir.
It's overly simplistic.
Well, for sure. Yeah.
It's closed loop is that it's always going to be in that sequential order.
Yep. Yes, sir.
It apparently gives equal weight to each of the steps.
Absolutely. Good point. Someone back? Did I see someone else? Basically, the problem with the simplistic answer is that, and you guys were getting at it, is that all your observations are filtered through the cognitive apparatus of the observer, and the observations can't be separated by the various internal mental processes of the observers. And the implication is that any description of that reality can be viewed through a variety of concepts that different individuals and groups use to represent that. There's all sorts of different points of view. We all have common experiences and different experiences. I see things one way, you see things another way. You're a pilot? Yeah, okay, well, you've been trained to see things a certain way. A grunt's been trained to see things a separate way. You're both Marines, so you have certain common outlooks. You went through the same basic training and stuff like that. I'm basically out of I got a degree in engineering. I'm 70 years old. You're what, in your 30s? Yeah, we've got different views. The digital world is all you've ever known. The digital world is only the last third of my life. You know, so you look at things differently. It's not to say one's right or one's wrong. It's just that different people have different cognitive apparatuses. And the question is, how do you evolve a relevant orientation as a group, like say you're a company in combat or a platoon in combat, for apprehending the complexity of the situation you're dealing with? You know, everybody can't use their own background. You got to work together. You have to have a common outlook. And how do you determine that? There's basically two ways for evolving and manipulating mental concepts to represent reality. One is analysis, the other is synthesis. In analysis, we break things down into its constituent parts and look at their relations between it. You can think of it as deduction, differentiation. Ultimately, it's destruction because you just take things to their parts. Synthesis is the reverse. You start with the parts and you're building toward a comprehensive whole. Induction in logic, integration in mathematics, or construction. You're building something out of parts. Those are the two ways we manipulate our mental concepts to represent an external reality. Now what I'm going to do is I'm going to try to illustrate this point by taking you through a couple mind experiments. We're going to look at the interaction of observations and orientation think of it as an introduction to the dialectic nature of understanding and creativity. Understanding can be thought of the analysis of pre-existing domains. By domain's a mathematical term. It basically means sort of a sealed whole. Everything inside that you're worried about understanding. Everything outside of it you don't care about. Creativity is analyses, plural, and synthesis. And I'm going to take you through Boyd's thought experiment and give an example of what we call the destructive deduction and the creation of a new domain. And to explain how this is, I'm going to describe a historical example, which is the evolution of cosmology. Now, does this trigger anything in anybody's mind? Because if it does, you can't talk at this point. But everybody else, I want you to join in. Let's see. Okay, let's look at analysis, understanding the context in the context of a single domain. Basically, what you do is very simple. You gather a bunch of observations about that domain, you break it down, and you look at it from a variety of different ways to try to, and then you combine those different perspectives into a comprehensive description. You take it apart, look at it from different angles, and put it back together. That's what analysis is. You can look at a pyramid, for example. A solid pyramid, that's what we're trying to understand here. Basically, if you look at it from the top, it's a square with intersecting diagonals. If you look at it from the side, it's a triangle. If you look at it from the corner, it's a triangle with a bisection. And if you look at it at the bottom, it's an opaque square. Basically, to understand this pyramid, you have to look at it from all those angles. We're not trying to understand what's inside it in this experiment. And then you correlate and combine those relationships among the perspectives by rotating it around and everything. And the point is that the dissection and reassembly can produce a richer understanding, but the constrained integration, basically the way you put these ideas back together, you only got so many options to put it back together, always takes you back to the same pyramid. You've got understanding, but you haven't invented anything new. That's the key point. Analysis is basically a way of understanding. If a person says he's an analyst and takes pride in that, it's a person who wants to understand more and more about less and less until he understands everything about nothing. I don't like being called an analyst, by the way. Now let's look at creativity. This is a thought experiment concocted by John. And it's basically replacing an existing order with a new order. Imagine 4 domains. Each domain is completely defined by what's encircled in them. Skier on a ski slope, the only parts it has are these. Speedboat, the only parts it has are these. Bicycle, similar, only parts it has. There's no relations between these domains. We can understand each of those by going through the same process we did with the pyramid. Now what I'm going to do in the next slide is I'm going to shatter the correspondence, or I'm going to begin to shatter the correspondence between the parts and the domains. Basically, we're going to know more and more about less and less until we got nothing. Let's see. So what I've got here is the first step in the shattering. Now, there's something not quite right in this picture. And does anyone have any ideas what that might be? Don't worry about being wrong. Basically, we're thinking of the parts outside the boxes, but the legacy of those boxes is still influencing what we see. Or more abstractly, the pre-existing domains are still constraining our orientation and imagination. When someone tells you we got to think outside the box, what he's saying is take those things outside the box, but the box is still there. That's no way to think about creativity. It doesn't get you there. It's a common thing, particularly in the business world. Well, we're going to come up with some new ideas. We're going to think outside the box. And what they're doing is, at most, they're doing that. And you can't get rid of the box. So let's shatter the correspondence further. Now we have no relations. What you got is uncertainty and disorder in a place of meaning and order. Now, how do you construct any kind of meaning out of this mess? Which now we're getting to coming up with new ideas, synthesis. Anybody have any ideas how they would go about doing that? See anything that would make you think that there's some meaning here? How about now? Any ideas? See any common qualities, threads, attributes, How about now? You got a guess? Right. You're the first guy that's ever gotten it. Have you seen this before?
Yes, sir.
Good for you. I've done this probably 50, 60 times. That's exactly what it is. The technology for that was always there. There's nothing new, yet it's a new idea. And the thing about it is, the original domains are now suppressed. You don't think about these anymore. The box has been busted, disintegrated, and you have a new idea. Now you can't just do that with anything because a lot of times new ideas aren't so hot. For example, the Germans came up with a new idea for a motorcycle in World War II, which was a synthesis of a tank and a motorcycle. And they used it, and some people say it was great. If you go to military gurus and stuff, there are fanatics who love these things. But it didn't take. And of course, some of the ideas are outright stupid. Well, not stupid, just totally impractical. And that's the point. It never hurts to remind yourselves that just because you've got a new arrangement doesn't necessarily mean it's a great idea. You've got to check it out. And the way you check it out is to determine its viability and its relevance. And you got to do that by looking at its internal consistency and its reversibility. Now, what that means is you take it apart and put it back together again. If it's an idea, the idea comes back together again. If it's a physical thing like a snowmobile, it comes back together again. And you also have to see if you can match it up to some kind of external reality. Going back to the snowmobile example, you have to determine if there's a market for it, if you can manufacture it at a competitive price. Is this thing some toy for, Aga Khan and no one else can afford it? Or does it have a much better matchup to the market? And essentially what you're doing here is your focus is changing. You're turning inward to refine the precision and subtlety of your observations. And the newer level of the precision description will eventually exceed the original precision. And when that occurs, you should expect to see mismatches cropping up and inconsistencies. Now this is a key point. Why do you do this? Why would you expect to see mismatches? And the reason is quite logical when you think about it. If you assume that they won't show up, that would be the same as saying newer, more precise, and different observations and interactions will always combine to produce the same synthesis as the older, more primitive ones. And that's nonsense. If you got newer things, there's different things. So it isn't going to combine. So what I'm going to get to now is a real-world example to try to clarify this point. This is really central to the idea of an OODA loop. And I'm going to take you through how our view of the universe changed over 500 to 1,000 years. This is, I don't think any historians or scientists would argue with what I'm about to show you. I put this together, but it's pretty conventional stuff in the historical literature. Basically, if we look at our orientation toward the universe, we're going to start with the Earth-centered universe. You've all heard of that. It was invented by Claudius Ptolemy, who was an astronomer and a geometer, a guy who understood geometry. And he created what became known popularly as the music of the spheres. The Earth was the center of the universe, and it was surrounded by 8 spheres that rotated around the Earth. And that carried each planet. And the planets were the Moon, the Sun, Mercury, Venus, Mars, Jupiter, and Saturn, basically what you can see at night. And they rotate smoothly around the Earth, but along complex curvilinear path. And because sometimes, like on Jupiter or Saturn, if you look at how it changes over the years, it'll go like this, then it'll come back, and then it'll go like this with each rotation. Its place in the Earth changes because, as we know, this isn't a correct description. So he developed this theory of epicycles, which is basically the planet was mounted on an epicycle, which can be thought of as a roller inside the rolling sphere. So it went like this around the sphere. Now this is before anyone invented calculus, there was no way of describing curvilinear motion. It's a geometric way of doing it. And it actually worked pretty well. It gave reasonable agreement for the timetable of the planets, but it had a problem. As more precise observations occurred, people climbed up on pyramids with better eyes and whatnot. They had to change it. They had to tinker with it all the time. They're constantly changing it to get it to agree. They're changing the epicycles a little. And after a while, the idea that this is God's creation starts to get questionable because man is constantly changing it. Psychologically, is this God or is this me? And it got weaker over time as it became more and more complex. And the ever-increasing focus inward, by the 19th, I'm sorry, I got ahead of myself. By the 1400s, increasing internal complexity of the Ptolemaic system had fatally weakened its internal coherence, and that set the stage for some new idea. Now, there were a lot of things that happened in the 200 years that the Ptolemaic universe, it took the Ptolemaic universe to go down the tubes. I think most historians would agree that these four things were crucial. I might have missed one or two others, but I don't think anyone would take these off the list. Basically, Copernicus came up with the idea that the Earth is going around the sun. And he was a monk, and he was sort of afraid to do it, so he kept it secret. But the problem with Copernicus is he assumed the orbits were perfect circles, so he had to put epicycles in his system, just like Ptolemy. And his predictions basically weren't as good as the Ptolemaic universe. Tycho Brahe was a Danish astronomer, and he was an amazing guy. He didn't use a telescope, and he assembled a vast database that everybody used until the 1800s. And he thought Copernicus was nuts, but he provided scientific data. Johann Kepler was a mathematician, and he came up with a precise matchup with a mathematical description. He used Brahe's data and his own observations to convert the Copernican system into a more precise map. And basically, he said the orbits are ellipses, and the pattern of motion was based on three laws. Orbits are ellipses. A planet moved around the ellipse, and it speeded up when it got closer to its center of motion and slowed down when it got further away, so it swept out an equal area per unit of time. And that he calculated that the square of the year, the time it took around to get it, was a constant times the distance to the sun cubed. That's a pretty amazing calculation, but it worked like a charm. And then you had Galileo, who basically developed mathematical precision and the experimental method, and he provided a basis in physics for looking at all this. His main contributions, and there were many others, was he invented the use of the pendulum as a precise instrument to measure time. He proved falling objects accelerate at a uniform rate regardless of the mass. That gets you to the gravitational, toward gravity. Inertia, he showed that a moving mass would keep moving until something acted on it to stop it. It was a precursor to Newton's idea of action, reaction. Yeah?
Sir, if I may ask, that slide about the inconsistencies, were you saying basically that sort of, this seems like a trail of inconsistencies here, right? Like you have the orbits the data aren't adding up, then you have the orbit, but we presume it's round, that's inconsistent and inaccurate, and sort of as they piece it together, they're eradicating inconsistencies from the puzzle, essentially. Is that what that bit was about the bottom two slides back?
This is an effort that was going on. Remember, it wasn't a focused effort. It was a little bit like the military reform movement that we were talking about. You had different people doing different things.
But is that what you meant by the inconsistencies when you start to analyze?
Oh, yeah.
Okay,
These are examples. I'm sorry.
Okay, no problem. So that's what we're
That's a
talking
good
about.
point. That's a good point.
Thank you, sir. That's
Yeah,
really helpful.
you're welcome. Please ask questions if this is getting confusing. And finally, Galileo used the telescope to postulate what he called the divine clockwork, and he used that showing the rotation of Jupiter's moons around Jupiter. Now the dogma at the time was the Earth's the center of the universe, and Galileo basically had scientific data, observations that said, well, it's not the center of everything in the universe because Jupiter is the center of something. And that he ended up in a trial before the Inquisition, where the Inquisition literally fabricated evidence against him. And the file is still in the Vatican archives, or it was in the early 70s. I assume it's still there now. It was discovered by Jacob Bronowski, where they actually made shit up so they could get him. Some things never change. So Newton took all these ideas and added a few of his own and came up with his snowmobile, which is the universal law of gravitation. And basically, he took the ideas of, oh, wait a minute, damn it. He took the ideas of Copernicus and Kepler. He borrowed for the more precise observations. He borrowed from Galileo and came up with the 3 laws of motion. And he had his own invention, infinitesimal calculus, because instead of using epicycles and trying to figure out this curvilinear motion geometrically, he could do it with differential mathematics, differential calculus. And he came up with an elegantly simple orientation where basically said force is equal to the gravitational constant and the relationships of the two masses divided by their distance squared. And what this did is it predicted the motion of the planets with stunning accuracy. He literally cleaned out his opposition within this is a period of about 200 years to get from Ptolemy to Newton. And he basically tubed everybody within 80 years, maybe less. I mean, he just wiped them out. About the only place where there was any debate was here, because Gottfried Leibniz also invented calculus independently, and he claimed he invented it before Newton. But Leibniz didn't come up with this. That debate went on. They hated each other, went on for the rest of their lives. Okay, so here's a new snowmobile, completely changes our orientation toward the universe. And its prediction, it's able to predict the motions, is far superior to anything else. So this is truth, at least for now. Now, what happened is Newton also made his discovery at the beginning of the scientific revolution and just shortly before the Industrial Revolution began. And his orientation helped shape the explosion in technology, and the new technology led to more precise and more subtle observations. And the result was an experimental evolution where they had the inward focus and more subtle observations set the stage for eventual mismatches between Newton's predictions and the observations. And the most spectacular of these was the Michelson-Morley experiment. Is there anyone here who hasn't heard of that experiment, or maybe none of you? The Michelson-Morley experiment was one of the most important experiments in science. Basically, they were trying to measure the speed of light in the 1880s. And Albert Michelson had invented an interferometer as the tool to make the measurements. And basically what it did was measure the differences in light waves by measuring the size and number of black and white bands or interference fringes when the light waves got out of step with one another. By looking at the differences in the interference of light waves, they could get a feel for how they differed from each other. So the aim of this experiment was to use an interferometer to measure the speed of the Earth through the ether by comparing the difference between the speed of light and the direction of motion and the speed of light perpendicular to the motion. Now, this is a simple experiment. Imagine yourself, you're in simple conception. Imagine yourself, you're in a car, you're in a convertible, and you're going 60 miles an hour. You throw a baseball at 20 miles an hour from the convertible straight ahead. that baseball is going to be going 80 miles an hour before it slows down. Now imagine if you throw it straight up. The baseball will be going 20 miles an hour up that way and 60 miles an hour that way. And the way that's that is what this experiment was based on, and that's known as a Galilean transformation. It came from Galileo. And it's implicit in Newton's theory, which depended on at least two universal constants. Newton used gravitation and time as constants. His whole theory was based on that. And I've read in his notes, he said at one point, if my conception of time is wrong and it's not constant, everything's wrong. Now, I've never seen it. I've read that he made this marginalia somewhere in his notes. And the Michelson-Morley experiment basically were shaped by that orientation. They assume the ether is an inertial medium in space. They didn't have a concept of space at that time. They used a thing called the ether, which was sort of a surrogate for space, that carried both light waves and the Earth. That was the key thing, that it carried the light waves. And they assumed the Galilean transformation. The speed of light in the direction of the Earth's motion would be the speed of light plus the Earth's speed. The speed of light perpendicular to the Earth's motion would be the speed of light. Just like the experiment with the baseball I just said. The problem was the experimental results were totally incompatible with that. It didn't matter. There were no interference fringes appeared, and basically that was equivalent to saying the speed of light plus any other velocity is equal to the speed of light, which was impossible under a Galilean transformation. And they did the experiment over 5 years, redoing it and trying to figure out what they did wrong, and they finally had to say, there's something wrong with Newton's theory. You have to understand that in 1880, Newton was like a god. You didn't say Newton was wrong. If you wanted intellectual legitimacy in economics, for example, you modeled your theories after Newton's things. The whole theory of microeconomics and the interaction of supply and demand is based on ideas of Newton, which is interesting because if you think about it, Newton was a physicist. He's looking at the science of dead matter, and economists are supposedly looking at a science of live matter. And of course, they don't have much luck, but contradictions don't seem to bother them. So anyway, there was a lot of turmoil in the late 1800s, and Einstein eventually resolved it. This gets complicated. I don't claim to understand everything. It's so far beyond our tactile experience. I just have a hard time dealing with. But Einstein, what he did was relatively simple in theory. He simply substituted, he changed the universal constraints. He kept gravity like Newton, but he changed, he said the speed of light is your other constant, and he substituted that for time. Said time can vary effectively. And the result was a new snowmobile, new orientation. The Galilean transformation doesn't work in Einstein's world. You had to go to a thing called the Lorentz transformation, which interestingly enough had been developed entirely independently in the 1800s. I don't know the exact history of that, but it didn't come out of nowhere because of the Michelson-Morley experiment. They had come up with this idea independently. And basically what it said was a moving object will appear to diminish in length in the direction of travel as velocity approves speed of light, and a clock will appear to be running more slowly. And of course you have the equivalence of mass and energy. Everybody's heard that. And most importantly, from a philosophical standpoint, he said the universe must be thought of, mind, as a continuum of space and temporal things. Space-time, mind, space-time. And that was a very, very different way of looking at the world. So what we see is that each new synthesis shaped the nature of future observations, as well as a research program for developing the concept description. On the other hand, if we look at the evolution from Ptolemy to Einstein, it shows how the interplay of observations and orientation produces a never-ending cycle of mismatches, destruction, and creation. You can't come up with Einstein's idea unless you destroy Newton's idea. You can't come up with Newton's idea unless you destroy the previous one, which in this case was Ptolemy's. Today we look at Ptolemy's universe as a contraption. Actually, has anyone ever seen his book? I've seen it, I haven't read it. It is amazing. It's about 250 pages of geometrical manipulations. It's absolutely phenomenal. It's a phenomenal piece of intellectual work. It just is wrong. And over time, so you have this cycle of increasing mismatches, destruction, and creation, but over time, your orientation to the world changes in a non-cyclical way. There's no going backward. Now, most engineers today still use Newton's work because it's great for approximating, but we use it knowing that it's an approximation rather than the absolute truth. Now, there's nothing, by the way, this whole thing on the evolution of cosmology is nothing that John did. It's something I did. I forgot to mention that at the very beginning to illustrate his point. Now, it's important to understand that up to this point, we haven't seen anything that other people haven't seen, at least in part. Thomas Kuhn, who wrote the book The Structure of Science, Scientific Revolutions, is probably the best example. But Boyd went further by arguing that there are theoretical reasons why this cycle is an inevitable fact of life. And those theoretical reasons basically lie in the makeup of our minds. He didn't say that, but they do. It's obvious. And his theoretical reasons were three. There was Gödel's proof, the Heisenberg uncertainty principle, and a second law of thermodynamics. Now, some of you people who have studied Boyd's work have seen references to this. He basically got to this toward the end. Gödel's proof is a mathematical logical proof. It came out in the late 20s or the early 30s. And an Austrian mathematician named Kurt Gödel came up with it. And the best description, qualitative description I ever read about it is Jacob Bernowski's, who said it was a remarkable and remarkably unwelcome proof. And the reason is, Gödel showed that any consistent system of axioms is incomplete. That is to say, it contains true statements that cannot be deduced from the postulates that make up the system. You had to appeal to a supersystem outside it to uncover those truths. What made his proof so devastating is that he proved it for the system of simple arithmetic, which is the simplest logical system in existence. That's what really was the killer. And Boyd came up with a generalization for it. He said, even though a system may be consistent, its consistency cannot be demonstrated within a system. You must appeal to systems outside it, which is totally consistent with Gödel's reasoning. These are Boyd's words. The Heisenberg uncertainty principle, I assume everybody in the room's heard of it at least. Basically, it dealt with Heisenberg. Werner Heisenberg was a physics experimentalist in the 1920s in Germany, and he was trying to locate the position and momentum of an electron. The only way they could do that was the only particle they could control to measure the position of an electron was another electron. And basically, when you'd use that, the answers went all over the map. And he concluded you can't simultaneously determine the position and the velocity of a particle. Particle being, at that time, was thought to be an electron. Now there's some question over whether an electron is a particle. The generalization is when the precision of the observer approaches the precision of the observed, the observer perceives uncertain or erratic behavior. Now this is based on an interpretation of a lot of interpretations of Heisenberg, particularly Niels Bohr, which we're going to get to in a minute. And then there's the second law of thermodynamics, which is pretty familiar. Basically, all natural processes create entropy, but the generalization can be entropy must increase in a system that can't communicate in an ordered fashion with other systems external to itself. Now, basically, entropy is a measure of disorder. The more entropy you have, the more disorder you have. So, and the only way you can reduce entropy in a system like your body is to take stuff in process it, and expel waste. If you can't expel the waste, you've got a lot of disorder going on inside. You have to be an open system. Do you have a question? Back there? No? Oh, I thought you did. I'm sorry. Okay. These are the reasons for the mismatches according to Boyd. And here's his snowmobile. And now we're getting into the heart of the OODA loop. Basically, he takes Gödel, Heisenberg, and the second law, and he combines them into a single statement. One cannot determine the character or nature of a system within itself. Moreover, attempts to do so will lead to confusion and disorder. If you want to understand the OODA loop, you have to understand this statement. This is the central statement in the idea. Talking about maneuver warfare doesn't get at this per se. Maneuver warfare implicitly embodies it. But if you talk about fourth generation versus third generation warfare, that the distinction doesn't get at that. And what we're going to see now is I'm going to show you how this lies at the center. I need to get something to water. Yeah. No. Thanks. Sorry. What the implication of these ideas is that we're facing a never-ending cycle. Wait a minute, did I skip one? Hold on. No, okay. The implication is the never-ending cycle of increasing mismatches, destruction, and creation is a natural manifestation of a dialectic engine, an analytic synthetic process powered by the continuous effort to survive and improve our capacity for independent action, what we said at the very beginning, and it's regulated by alternating cycles of entropy increase toward more disorder and entropy decrease toward less disorder. Basically, that's what drives it in the sense. When you sense that your disorder is increasing, the pressure is on to reduce that disorder. Now what we're going to do, and I'm coming up on the worst slide in the whole briefing, we're going to probe a little more deeply into the nature of observations and the relationship between the observer and the observed, and how and the way we synthesize these observations into a useful picture of reality. Now, we're also leaving the confines of Boyd's paper. This is my stuff in the next couple slides. And this is the monster slide. I'm going to have to read these things. Basically, you can categorize observations by the interaction between the observer and the object of observation. In classical physics, which is basically Newton and the philosopher Simon Laplace, who was Newton's philosopher basically, the universe is a system of reversible deterministic events that exist as an objective reality independent of the observers. Observations are events in themselves, and a complete description of these events is theoretically possible. Uncertainty about the description is therefore a result of ignorance. That's basically, when you hear someone say we're going to take an objective look, they're saying we're abiding by this view. Relativity under Einstein is a little bit different. Einstein agreed that the universe was a system of reversible deterministic events that exist as an objective reality. But he said one's description of that reality is dependent on where the observer is in the system. Between each event and the observer, we must pass a signal, a ray of light, for example, which cannot be taken out of the observation. The fundamental unit of observation is the relation between the event, the signal, and the observer. So here we have pure observation. Here we have the relation between the event, the signal, and the observer. Uncertainties about the system as it is are the result of ignorance, but some of these events are unknowable to man because of the nature of the signal. You can't apprehend two simultaneous events that are light years apart. In fact, it has no meaning. You know, an explosion on two stars, 100 light years apart, simultaneity means nothing because it takes 100 light years to travel. Quantum mechanics, this is the most difficult one, I think. quantum mechanics and the principle of complementarity. This is Bohr's interpretation of Heisenberg. Events at the atomic level can only be described in terms of alternative possibilities and relative probabilities of occurrence. Heisenberg showed why it was impossible to make precise simultaneous measurements of a position and momentum of an electron. Bohr interpreted that to mean the interaction between the object of observation, which is the quantum system, and the observing mechanism is non-decomposable. No single observation or observing mechanism can completely describe the system, while the various observations make the complementary portions of that same system. It is impossible to combine them into a single, complete description of the whole reality. Basically, it says, you know, once we go inside this thing, we can't separate different things from the observer from the observed. And then in natural science, which is evolutionary biology, in natural science, biology, culture, epistemology, Darwin, Conrad Lorenz, Joseph Campbell, Hall, and Boyd are sources of this. Events in the external world are perceived through an evolutionary cognitive apparatus. That's a neurosensory system that acquired its present form through its interaction and adaptation to the subset of events in the outside world that affects survival. Since the sensing mechanisms superimpose partial images of the outer world on fluctuating mental states of the neurosensory system, the internal neurosensory organization, it is necessary to compensate for the physiological and psychological mechanisms in the observer. Now, one of the things, if you look at defense analysis, warfighting, computer programs, and things like that, they're basically treating the game as if it was a Newtonian universe where you have objective observers and you're making decisions and you win or lose depending on how smart or stupid you are. But this is what's really happening. This is where you guys exist. This is a much more complex situation from a standpoint of cognition. This is the most difficult thing there is. So we can summarize. Newton and Laplace, and I would add most defense analysts, social scientists, and economists, say there's no interaction between the unit of observation and the object of observation. And that leads to the sterile theory of an objective or absolutist observer in social sciences. How many times have you heard the thing, we're going to take an objective look at this? Oh, and then now we have to make some assumptions. Of course, the assumptions shape what you see. So is that objective? Einstein said there's no interaction like them, but he had a different unit of observation, the object, the signal, and the observer, and that led to the sterile theory in social science that everything is relative. That got to be a real fad for a while, that everything is relative, and that it even got into the moral level where you had moral relativity. Heisenberg and Bohr said, essentially we have a one-way interaction. The process of observation shapes the object of observation. And because of that, because it shapes, our units of observation are possibilities and probabilities. And the evolutionary approach, Darwin, Lawrence, Boyd, it's a two-way interaction. The observer, the observing apparatus shapes and is shaped by the object of observation and the interaction of environmental pressure, which is coevolution. Let's see what time we're just about done. The basic units of observation are the subset of external events that set the observer's survival.
Sir, a question.
Yeah, where? Oh, I'm sorry.
So to clarify, is the integration of these theories a framework for theory of thought, or is it meant to be proofs?
I'm sorry, say again?
Are these meant to be proofs like you showed in the slide earlier, the axioms?
Axioms? No, I wouldn't call them axioms. Those are just the facts of the different approaches. I'm not sure I understand your question.
They're bringing in like Einstein, Bohr, and Darwin, various levels that don't necessarily cross-apply.
I'm sorry, I'm having trouble hearing you. Let me.
The different theories that are brought up here,
Yeah.
are they being used as examples of methods of thought, or are they being used as scientific proofs?
Oh, they're basic assumptions and methods of thought. Like when you hear someone say, I'm going to do an objective analysis of this, he's basically somewhere up here. If you try to do an analysis based on evolutionary ideas, that's a much more complicated way of doing things. Well, that's one reason why most of the stuff we see is up here. It's easier to do.
It feels to me that we're crossing the bridge between the colloquial use of a lot of these theories and the scientific use.
Oh, yeah.
So at what point does it become tautological?
Tautological?
Like the,
I don't know. That's a good question.
If these, like if the system that the system of thought that we're describing that comes from all of these things is based on these things, but the system that we're describing is that all humans are wrong and systems always change, at what point?
I don't think it's a question of right or wrong. It's a question of, the Ptolemaic universe, you could navigate by it. It was designed for navigation. You could navigate by it. It didn't represent physical reality as we currently understand it, but it wasn't necessarily wrong because it worked, at least for a while. The same with Newton's stuff still works for 99% of its applications. You get into electronics and space are the two areas where it doesn't work so well. But earthly applications, it still works. So I'm not sure that answers your question.
I suppose what I'm asking is, was Boyd's integration of these theories more meant to be an analogy than a scientific theory? Was it meant to actually integrate?
He was trying to understand how his own brain operated. At some point, that translated into an OODA loop. He wanted to understand why like I said at the very beginning, why he came up with the idea of energy maneuverability, which was a creative breakthrough when much more well-qualified people didn't. So he came up with this. Now Boyd never saw this stuff. This is me. When I tried to point out where I departed from him. Maybe the thing to do is you're raising a really important point, but maybe we could come back to it. Okay, let's see if your point gets of more concern or less concern as we go through the next slides, because I'm not sure which way it's going to go. No one's ever raised that question before. It's a smart question. I don't know whether you're right or wrong. So I guess I owe you. Anyway, let's try and go. And you want to come back to it? Okay? All right. Okay, now what I'm going to try to do here is bring those ideas together to see what he was getting at when he said, machines don't fight wars, people do when they use their minds. And, remember his snowmobile, one cannot determine the character or nature within itself, moreover, attempts to do so lead to confusion and disorder. That came from, the integration of Heisenberg, Gödel, and the second law. Now, going back to I'm going to go over here. I can see a little better over here. Excuse me. Going back to the simplistic description of the OODA loop, our discussion of the relationships among analysis and synthesis and observation and orientation shows that our orientation is the crucial part of the OODA loop. That's where the action is. How we filter those observations through there, how those orientations shape, how our worldview shapes our decisions and actions. And the mechanical cycle says nothing about the importance of that orientation. That's the fundamental flaw of it. It just doesn't really describe anything useful. And we know that orientation shapes how we see as well as what we see. And that's what going through the cosmological thing showed. It shaped how we see is what we see, and how we see changes over time. It evolves, getting back to your biological point, over time, which brings us to Boyd's conception of the OODA loop. Now, have people seen this graphic before? I think most of you probably have. Well, what we've been working on is trying to understand what's going on in here. And so what I want to do is go through some implications of this idea. And remember, this diagram is just an abstraction. It's a model of sorts. You know, when we had a long discussion in the late 80s when we were thinking about this diagram. And it was Chet Richards, Boyd, and myself. I mentioned Chet earlier. And you know, we were worried that, you know, people see that, well, what they're going to do is they'll put it on a heads-up display in a cockpit, and you work your way through it. Or we'll put it in a CIC. You know, and that's not the idea. It's a way of thinking about thinking. You know, it isn't going to help you directly in a combat situation. You know, well, it could really hurt you. So the following charts are parts of the OOLET model. They were developed jointly with Chet and myself after John died. The first chart, that was John's drawing, and we worked on it together, but it was his. What you're going to see from here on out are what Chet and I, how we took that thing and tried to look at the different implications of it. First of all, remember the simplistic notion of the loop was very mechanical. You just go around a circle. That's not the case. This is an organic conception because you have learning going on in here. And it can be thought of as a complex interplay of homeostatic control loops, going back, in a mental struggle to evolve a matchup of living organisms with their environments. And you can apply this idea to individuals, groups, and even cultures, obviously with different levels of abstraction. So we're not dealing with a mechanical idea. We're dealing with an organic idea, which, you know, gets back to the biological question. Now, if you look at this, the second impression is that if you look at the only place where the loop comes into contact with the external environment, the green area here, is either through observations from the external environment or action on the external environment. The rest of it's internal. And internal operations of any kind of system like that have hazards of inward focus. We've already seen where that takes you. You get confused. And that brings us back to Boyd's snowmobile. One can't determine the character or nature of a system within itself. Moreover, attempts to do so will lead to confusion and disorder. And here's the implication for strategy and conflict. If the interior operations of an adversary's OODA loop can be induced to hijack observations and actions, then his OODA loop will become disconnected from the environment and could be induced to collapse into confusion and disorder.
So you mind going back a slide, please?
Sure.
Can you expound further on the right-hand side when you said sometimes that action, well, I don't know if you said it, but you were talking about the inputs that we have to input on the environment in order to start the loop. Does that make sense? So on the right-hand side,
Yeah.
so the action of the test part,
Yeah.
I guess the question is there environments that we find ourselves in? So the application is usually in order, in sequential order. Which
You don't want to go backwards. You want to go to the next slide.
Okay.
Let's start looking at the end. This is a way of getting at your question. It's a good question. Let's start looking at the internal workings. In other words, the areas in the white. There's basically two types of loops, and there's one of these control loops that's very different from all the others. Does anybody have any idea what that is? Anybody willing to guess? Yeah? I'm sorry, I still can't hear you.
The implicit guidance and control of the top line?
Well, that is a little bit different, but that's not the one. That's a good point. Implicit guidance and control. Basically, implicit guidance and control, which we're going to come to, is when you intuitively know what to do and everything, and you don't have to go through any kind of sequences. Like in a basketball game, You know, when you get ahead of your adversary and you're moving faster, you can sort of anticipate what's coming next. You don't even have to think about what you're going to do. It just starts coming naturally. Everything seems to slow down, get in slow motion, and you're getting further and further ahead of the game. That's when that comes in. That's actually, when you're in combat, that's where you're operating. You know, if you're going through this, if you're going through this kind of activity here, you're going slowly, and that's not good. But, you know, the question is, how can you get there? You know, a good example, and we've talked about this before in some of the other lectures, are, you know, free play exercises are a great way to build up implicit control loops, where you intuitively get to know the people you're working with so you can anticipate what they're going to do. You don't have to say anything or anything. You do it, and they just do what they have to do. That's... So, anybody else got a...
That's it, feedback.
Huh?
The feedback.
Which feedback one?
Either.
These?
Yes, sir.
Those are standard feedback loops. Those are negative feedback loops, which are like feedback loop on a thermostat. You know, deviation. If you deviate from the target, you move to the target. But you're right. It's this one. This is implicit guidance and control, but it's also a feedback into observations. This is the bomb in the loop. That's the one that's very different. See, there are two types of loops. There are feed-forward loops, and these are loops that power the system, whether it's the implicit one that we just talked about here, or the analytical part, which takes time, but develops an interaction. There are times when you may have to do that. When you're in combat, you don't particularly want to be doing that. You want to be able to operate in another domain. But if you're totally lost and don't know what to do, that's when you're stuck doing that. And of course, your time cycle is getting stretched out, which makes you vulnerable. And then the other ones are feedback loops, which are in the yellow here. These are negative feedback loops, and this is the one that's different. Because that's positive feedback. The orientation shapes the observations. It basically sees what it wants to see. It's a little bit, an example of a positive feedback loop is putting a microphone next to a speaker in an amplifier system. And it just generates noise and runs wild until something breaks. And basically, we all have this kind of loop. It's based on our genetics, our traditions, our previous experiences, and how we integrate all that. And it may also have a factor of new information involved in it. And this is what's really dangerous. We want our adversary to be really operating up here, because he's not interacting with his environment. Basically, he's seeing what it sees as opposed to what it is, and that means the orientation can distort observations and disconnect the organism from its environment, thus isolating the loop, making all loops prone to collapsing and confusion and disorder. And we have a term for this. It's called incestuous amplification. And PJ, we were talking, who was I talking to about PJ Trembley's thesis? Yeah, remember how PJ used that term? PJ was trying to explain what's going on up here. Now, the other thing is that because this is implicit, it happens fast, just like this. Here, your problem is one of creating new repertoires, and it's slow. So you want to operate fast. You want to be here. You don't want to be here. But there's a lot of temptation to be here because it's easy. You have an idea, you project your idea onto the environment, you see what you want to see, and you go for it, right off the cliff. So explicit is difficult and can feel unnatural and unnerving, and it's regulated. It may require a destructive deduction, which really slows you down if you're in a combat situation. You don't want to go through this creativity type stuff in a combat Did someone have a question over here? Yes, sir.
So if you go back to the slide, you talked about the positive feedback loop. You mentioned that it's disconnected from the environment. But aren't the negative feedback loops also disconnected from the environment?
Pardon?
So
I'm having trouble hearing you.
The positive feedback loop is disconnected from the environment, correct? But aren't the other two feedback loops also disconnected from the environment?
Yeah. Well, the implicit guidance and control goes into the action, and then it connects to the environment.
But if you're in the feedback loop for that.
But this one here is totally disconnected from the environment. You think you have observations coming in, but your mind is telling you what you're seeing rather than what is.
But the other feedback loops also are not connected.
It's hallucination is a good example of that kind of loop. When you have a hallucination.
How come the other feedback loops don't also create that same hallucination? They're not connected to the environment either.
That's right. They aren't. But because these things are telling you, based on the interaction with the environment, these things are telling you what your action and decision, how that affected it in the new observations. Assuming everything's clean, then what you have here is a system that's regulating itself, albeit slowly. It's slowly, and you may realize that you're not interacting correctly based on how the observations are coming out. Your actions are creating the wrong situation, and at that point you may have to do, wait a minute, the creation of the new repertoires, which is where, basically, if you think about it, going from the Ptolemaic universe to the Newtonian universe was the creation of a new repertoire. That's a very, very difficult thing. Okay, are you ready to go now?
I think this clarifies.
Oh, good.
Yeah, because what I had an issue with was the statement that we cannot compare the character nature of a system within itself without creating confusion and disorder being pulled from other systems that using that system to analyze. But what I have an issue with is not the determination that you can get better results by bringing in outside observations, but that it is possible to get to the right answer within the system.
Oh, sure. It depends on what you're trying to do. That depends on what you're trying to do.
You either feedback loop is still within the system. It's still internal.
Are you saying this isn't so bad? This is where the danger lies.
The same as what was just pointed out, is that even the negative feedback loop.
Oh, negative feedback loops are basically good. In cybernetics, it's a control loop that basically you have a target, and a negative feedback loop measures your distance from your target and changes the variable in a way that moves you closer to the target. A positive feedback loop moves you further away. And that's why positive loops are bad. They can be very bad. But a negative loop, the problem with a negative loop is I guess if you're thinking of it in terms of creativity on a battlefield and things like that, it's very prosaic. I mean, there are certain times you use it because it just makes simple common sense. It's not that you throw out everything, but basically you're saying, I know I thought I was going to see this. This is what I've seen it. I'm going to move this way, and it's going to make things better, and it did make things better. But with this thing here, you have the same situation, except it makes it worse. Now remember, one thing I haven't given, unfortunately I haven't given this lecture in a while, and I've sort of left out one important point, is all these operations, like when we were going through the experiment, through the destructive deduction and building the first snowmobile, imagine how it works if someone has a gun at your head. Remember, we're dealing with military strategy. There's menace everywhere. And so your loop is under menace. And so there's great temptation to, you've learned all your dogma and doctrine and everything. It's just to say, well, it doesn't exactly fit, but I'll make it fit. Yes, sir.
Is that similar basically to Einstein's comment that definition of insanity is just trying the same thing over and over again and just getting different results?
Yeah.
And that's what we're worried about with that loop there.
Yeah. It's a person who's hallucinating is basically going through that kind of loop. a person who sees what he wants to see to deal with any kind of problem because he's been trained to do that. He sees one of the dangers of analogies is the analogy can capture your imagination and cause you to see something that fits the analogy. You have to be very careful about using analogies because they can take you right off the cliff. On the other hand, most really creative people like Einstein reasoned by analogy, but they were also very, very disciplined in determining determining the analytical thing to see if the analogy worked. And in a sense, reasoning by analogy would fit up in there. Now, it doesn't mean Boyd reasoned by analogy. In fact, his best friend was a guy named Pierre Spray. You may have heard of him. Pierre is the ultimate empiricist. He's a brilliant engineer, and he basically does things empirically. And if it's not empirical, bullshit. I don't want anything to do with it. And his best friend, John, reasoned by analogy, which Pierre thought was absolutely insane. And I remember we had a long discussion one night after we had been drinking too much, and it's the only time I've ever seen Pierre spooked by something. He says, he says, the guy thinks wrong. He does everything wrong, but he comes up with the right answer. He says, and I'm an empiricist, so I got to agree with him. That's the problem. Yes, sir?
So it's just jumping out at me like an elephant in the room. That upper left-hand corner in red is exactly what Russia's done to us recently. What's your reaction to that hypothesis?
I'm not sure I understand it.
Well, if you think about that loop, perception is reality. Doesn't that fit the positive feedback loop, where you're seeing what you say you want to see as opposed to what?
Oh, you mean as far as the interference with the election and all that?
Well, right, but just the idea.
The Democrats have done that to themselves.
Or are we adopting what is perception as reality? So I want to know what.
Right, but that's not necessarily what Russia did. It's what we did to ourselves.
Right, potentially. But do you think we're in that? Do you think the country is in that upper left-hand corner?
I think we're getting damn close to it.
Say again, sir?
I think we're getting damn close to it. I'm not sure we can use this to forge a political program for curing the ills of our country, but
our observation loop, or is what we're.
I think if you look at the media, if you look at the mass media, and it doesn't matter whether you're looking at the conservative mass media or the liberal mass media, there's a lot of this going on. Where they're just pumping out preconceived notions of what it is. They see things they want to see, then cite it as proof. They ignore things that disagree with it. It is incestuous amplification that's going on. And it's dangerous as hell. All you have to do is look at what's happening. We don't want to get into a political mess, because God knows where that'll end up. I think we're on the same side of the thing, but let's not. I'm not sure.
But there are other things that we've seen with maybe even weapons control.
Absolutely. Absolutely. That's a very good comment. That's right. Look at the advertisements. Look at the Navy. Are you guys familiar with these the surface ship collisions they've had? Have you seen any of the recent articles on what's happened? Basically it was a total mess on the bridge. Basically, we have these bridges are on advanced destroyers, Arleigh Burke class or Spruance class things. They're not old-fashioned deteriorated equipment, and basically what all those systems have been sold on, and many of the systems they're trying to get you guys to buy, is this: we're going to have total information awareness. We're going to have total situation awareness. We'll know exactly what's going on. We're going to lift the fog of war. And essentially, that kind of advertising, the kind of advertising put out by the contractors is conditioning a lot of people to accept that kind of nonsense who should know better, in part because maybe they're nearing retirement and want a job with a defense contractor for whatever reason. And really what you have is a system that's just talking to itself. And in fact, one of the things that during the military reform movement in the 70s and early 80s, one of the problems was that we really antagonized the technology community because we were pointing it in a very different direction. You know what? You know what's an interesting thing? You look at these destroyers that are hitting other ships, and you have the CICs are a mess. The watch positions are crazy. I'm not sure one person on the bridge now can do what's needed. You know, you have different functions that are spread apart. But if you Jesus, I lost my train of thought. That's what happens when you're over 70. Have any of you ever been on an aircraft carrier? Have any of you been ever up there on an aircraft carrier with an air boss? Isn't it amazing how little technology is involved in what those guys do up there? You basically have 4 seamen around the air boss who's telling them where they are in the stack. You got colored guys out on the deck where the air boss can just look at the color and understand what's going on, and he shouts when things are out of order. And it's basically a total mission orders type situation. As soon as the Navy lines up to go to war, they get off the deck, they go into this, centralized command and control thing, no initiative or anything, go out to do their strike. They come back, they shift into the decentralized role to land on the carrier. Because what's the most dangerous thing they do? Is getting on and off the carrier, And what they've done is they've developed a human-centric system that works pretty well. I mean, a carrier is a crash waiting to happen. And
But that's a relatively closed system. It's finite, and they're not going up against any humans.
well, you're right. But they are going up against accidents. So the unexpected occurs.
Sure.
And you're right.
There's no
But
opposing wills.
yeah, I agree with you totally in that regard. I'm just illustrating a point where you have a situation where the Navy uses a totally different concept of situation awareness in an area where lives are really at stake on a day-to-day basis, and they get away from it the moment they go from that. That's all. And if you look at it, it's very tightly related to what the contractors say is the nature of war, which is total situation awareness. You look at, read these journals that are coming out now. They're having basically, you'll pardon me, but it's an orgasmic splurge of technology because they think all this money's coming in. This crap that's being floated as ideas. For people on the infantry, they got you all cluttered up with batteries and goggles and things like that. You have to plug the infantryman into Hoover Dam, to get the electricity he needs. I'm exaggerating, but you get the point. Anyway, we're just about done. This is, of course, this is where, well, wait a minute, what did I do? This is where we want to put our adversary. It's sort of where we don't want to be. And let me give you some examples of how this has occurred in the past. They're well-known examples, and you're probably familiar with most of them. You don't need to take pictures of this because they're going to be hard copies given out. Let's look at examples where the orientation hijacked observations. France 1940 is a classic case. In fact, it was a double hijacking. The French had the Schlieffen mentality, so they built the Maginot Line to protect themselves, and the Germans decided to do something different. Most of you know what that difference was. I won't have to go into it unless you want me to. But they did something totally different, and the French walked into the bag. What's interesting about this is the Germans also had the Schlieffen mentality when they were planning the thing. They were going to do the same thing they did in 1914, but then they lost their plan. It was captured, and Manstein sold the plan that worked to Hitler. The general staff had initially told him basically to pound sand. And so the French weren't alone in that. It's just that the Germans adapted a little better. In France in 1944, in the invasion, we had the patent deception, which of course was a very elaborate deception plan to make the Germans think we were going to invade from the Pas-de-Calais and that D-Day was a feint. And we could run that deception because we had broken the German codes and we could monitor how well they were buying into the scam. So if the scam wasn't working, we would know about it. And that's one reason why it works so well. But that's the kind of thing you really can't depend on most of the time. It was a wonderful advantage that we had. In Vietnam, we measured success by the body count, and tons of bombs dropped, which are inputs. Well, tons of bombs drops an input, it doesn't tell you what the bombs did. And the body count, that's a really ambiguous measure. You know, POW captures, like the POWs who were captured up here, are a much better measure of how well you're doing, because they're an indicator of morale and everything. And the other thing is, in guerrilla warfare, you don't start getting into battles and running up the body counts on both sides until you're winning. So is the body count measuring success or failure? It's kind of scenario dependent. Yet we managed that whole war. We regulated that war by body count. And of course, that was one thing that got the reform movement started, was the stupidity of that approach. Propaganda example is, you got the Nazi demonization of the Jews was basically bought into by the majority of the German population. You know, the good Germans who said they didn't want to have any part of it, but they went along with it. And that's because of what was going on up here on the mass OODA loop. Saddam's weapons of mass destruction. We did it to ourselves. You know, we knew in the Pentagon, I got out just before the war. I was not in the operational end of the Pentagon. I knew, even where I was located, that it was all bullshit. Everybody knew it. It was common knowledge. I mean, the soldiers out in the field probably didn't know it, but people in the Pentagon knew it. Intelligence guys knew it. People who had access to intelligence guys knew it. But it was used to basically cause this kind of activity to go on. And of course, the counterexample is, you know, you have to do, the way you prevent it is a kind of mentality that these guys exhibited, except you got to figure out how to do it bureaucratically and quickly in a combat situation. So we can sort of end with this slide. What we're dealing with is an analytic synthetic interaction, which is the mental orientation connects the organism with the external world. And it's an evolving, open-ended, far from equilibrium process. Now, that's a precise term in physics. It basically means it's a growing system. It pumps in stuff to get energy, information, and matter, and expels waste. Governed by control loops embodying positive as well as negative feedback. The entire loop, not just orientation, is an ongoing implicit cross-referencing process of projection, empathy, correlation, and rejection. And basically, it's an unpredictable evolutionary phenomenon, which brings us back to the thing you thought we left out, which we did on that one slide. And it's always prone to chaos. And that's the nature of the beast. It's always prone to chaos. On the other hand, when things go out of whack, we see something new and strange, and that's how we learn things. And that's that. What happened? No, that's that. So any questions? Do you, young lady, are you satisfied?
Yes, thank you.
Huh?
Thank you.
Okay, okay. Any more questions? Then we're done.
Right, Mr. Spinney mentioned that we have hard copies of the brief. We do not have hard copies here tonight. Obviously, this audience is pretty diverse because people heard about the brief from other people, so I don't know everybody's here right now. What I will do is tomorrow I'll send out an electronic copy of this brief to everybody that I originally invited, and you can find your point of contact from there and get a copy. Does that sound good? All right, let's thank Mr. Spinney for his time today.
Yeah, thank you.
Do you have a few minutes to say
Sure,
afterwards
yeah.
for individual stuff questions?
Yeah, sure. Yeah, I got plenty of time.
Great, thanks, Trevor.
Oh. Ooh. Yeah, I'm tired. This is not the